There may be times where we are given the error of estimate for our confidence interval and it's forced upon us. And we know the confidence interval level that we want to have for our estimate of our population proportion, but we're needing to find out what sample size we need to grab in order to make those conditions true. So when we're doing a problem like that, it's a finding the sample size question. They force on us the confidence level and they force on us the error of estimate, and we need to report how many we need to include in our sample in order to form our confidence intervals that will meet that requirement. Well, here, when we look at the setup of the question, we can identify some key pieces in the wording of the problem that tells us that it's this type of a problem and what formula to use. So it says a beetle is infesting a species of tree in a forest. Let P be the proportion of trees in the forest that are infested. If no preliminary study is done, how many trees must be sampled to be 80% sure that the point estimate P hat will be within 0.05 of the population proportion? Okay, so one of the key indicators here is it's asking me how many trees must be sampled. Now they may ask us sample size questions when I'm doing confidence intervals for a population mean or when I'm doing confidence intervals for a population proportion. So as soon as I see the how many part of it, I know it's a sample size question, but I'm not really sure which formulas to go to yet. Now when it says how many must be sampled to be 80% sure that the point estimate P hat will be within 0.05 of the population proportion, then I know it's a sample size question with the population proportion parameter that we're working with. Now under that heading of sample size questions, there's actually two different formulas they give you. They give you a formula for population proportion sample size if you don't have a preliminary estimate and if you do have a preliminary estimate for P hat. When we look at this again, it says no preliminary study is done. So if there's no preliminary study done, then the formula that you would use for sample size is n is equal to z sub alpha over 2 quantity squared times 0.25 all divided by e squared, our error of estimate squared. So this is the formula we want to use when we're trying to find sample size for a population proportion and I don't have a preliminary estimate. Now, looking back into the information, we need to figure out what it is that we can pull from there to fill in these other slots to be able to do our calculation. So we have our E, our error of estimate. That's how much we're allowed to go on either side of our point estimate. And usually the E is the value that follows a wording within or that you span from a lower to a higher and you need to take the half of that span, that sort of an idea. So within 0.05, that's my E. So that goes in for the E and I have my 0.05 quantity squared. Next up is the z sub alpha over 2. That's the critical value that you would have so that you get 80% of your distribution spanning either side of your point estimate. So when you're looking at the 80% with a normal curve, we want to have 80% be the amount of the area so that it falls between my negative z to my positive z. And we want to get this critical value back, and that's what we use for our z sub alpha over 2. Now these are a lot like the problems that you did earlier in the semester where you were given the probability or the percentage and you wanted to get the critical value, the z-score back. And you can do this either by reading the information backwards from the table or from going to your calculator that has an inverse norm setting on it. And that's the way we're going to do it. With the inverse norm, because we want to go backwards from having the probability to get to the critical values, INV norm, this is found underneath your second vars, the distribution key. So if you go second VARS, you'll see that the printing above that is DIST. And under that, you'll find inverse norm. Now the way that the syntax is for inverse norm, the programmers have written it so that it's expecting the area that's forever left of your critical value above the span within the critical value, comma, mean of your distribution, comma, standard deviation of your distribution. So if we want 80% on either side of it, and I'm trying to find that z, the calculator is expecting you to give as an input to it how much area would be to the above that number line that goes forever left. That's what the input is. So I need to figure out what that area is so that it would coincide with the same stopping point as if I had 80% on either side. Well, remember, for a normal curve, we have perfect symmetry through the vertical line that goes through the mean. And so if I want 80% on either side of it, then I would have 0.40 above the value of the mean to the z-score, and 0.40 area from the mean down to the negative of that z-score. And since I have a total of an area of 1 under the curve, then 1 subtract 0.80 is 0.20 that has to be split evenly amongst the two tails. So this tail is a 0.10 and the top tail is the 0.10. But I'm more concerned with the one that follows the area that's to the left, because that's what the input is expecting. So if I have my 0.80 and then plus the 0.10, that gives me from this cutoff down would be a 0.90. So we're going to go INV norm of 0.90, comma, the mean of the standardized score, the normal distribution, standard normal curve is 0, and its standard deviation is 1. So when you put that into your calculator and then you push enter, it's about 1.28. So that's what we're going to put into our z sub alpha over 2, 1.28, and that's squared, and then times the 0.25. So now going through and running those numbers into our calculator, we have 1.28 squared times 0.25 divided by our 0.05 squared. And when you do that, we get 163.84. Now with sample size, you always want to round up to the next whole number. Even if this would have come out to be a 163.01, I would round up to 164. You always need to go up to the next whole number, because if you round down, you don't have enough in your sample to meet those requirements. So we're going to write our n is equal to 164. And that's how large of a sample I would need to take from the trees to be 80% sure that the point estimate p hat will be within 0.05 of the population proportion p.